Hope you are having a good day till now. We have come to the presentation of my last and final paper. Once again, this is Sriram Jayaraman, currently pursuing my Masters in Cybersecurity at the University of Waikato. The current paper that we are discussing is titled Human-centric Data Dissemination in the Internet of People, Large-Scale Modeling and Evaluation. Even though the title is scary, the paper is just the opposite of that. We will get to that in some time. This paper was presented at the Transportation as a Service TAAS Technology Conference in 2018 over at Coventry University, England. So what is the problem that we are dealing with in this paper? The paper tries to solve the problem of mitigating the unsatisfactory level of evidence behind the application of the recognition heuristic for the dissemination of data in the Internet of People. Now, taking a step back, what is the Internet of People? IoP is the paradigm that signifies the depiction of move of Internet towards the edge nodes and viewing Internet from a human perspective rather than the traditional viewing as based of infrastructure. And recognition heuristic is a scheme that helps the brain to assess relevance of an object based on its recognition level. You can think of it as a model which incentivizes recognized assets better and tries to recognize all assets. Moving on, while initial evidence about its effectiveness is available, the evaluation of its behavior in large-scale settings is still unsatisfactory. Previous evaluations of this kind of systems have been carried out in small-scale scenarios, that is a few hundred nodes and content maybe, while the performance of recognition-based data dissemination for opportunistic networks in a large-scale realistic scenario still needs to be assessed. Again, what is an opportunistic network? An opportunistic network, or ONs in short, are networks that mimic human characteristics to perform message routing and data sharing. For example, a knowledge that you might have can be useful for a friend, or the vice versa. This concept is replicated to networks where neighboring or interacting networks share messages and data, if that makes sense. Earlier research has successfully demonstrated the viability of embedding human cognitive schemes in data dissemination algorithms for ONs. Also, the space of harnessing IoP with distributed sensing, mobile edge computing, mobile multimedia networks, and new services for smart cities is already probed. Exploiting social information of users for data dissemination is also a field that is extensively researched upon by the likes of researchers such as Contemplace and Socialcast. Hybrid simulation solutions have been used in computer networks, IoT, biological and medical systems, and operations research. Usage of analytical model based on a single community of users is already done, something which this study tries to extend. The author's idea is to use recognition heuristics, which is a branch of cognitive heuristics, to disseminate data based on the likeness of data being recognized by nodes within a community and for nodes interacting with other nodes outside the community. What does a community mean here? A community can be a family, a church group, or a local boy band to start to relate with. Nodes are actual human beings interacting within and between communities. The idea is to obtain relevant data from a node in a topic that it knows it is interested in. These topics are called channels, and nodes subscribe to both data and channels from other nodes within and between communities. While other solutions have existed similar to this, this is the first of its kind with a large-scale data using hybrid evaluation model. Traditional studies have either used an event-based model which triggers data dissemination with any event associated to it. This becomes complex with the increase in nodes. And mathematical models have too much abstraction to them, which is obvious as math is pure abstraction for those who don't understand it. This hybrid model the study uses combines the best of both worlds by having an analytical model which is event-based within a community and a mathematical model for inter-community dissemination. Moving on, to understand how the research is evaluated, we would need to understand two terms, hit ratio and channel recognition. Hit ratio is nothing but the possibility that people get the data items they are interested in, which is the ultimate goal. Channel recognition is as simple as it sounds. It is the ability to recognize net channels in the data dissemination process. The model is tested on multiple levels. With a steady state analysis inside a single community, they were able to predict the evolution of the dissemination process over the transient phase and also time when the steady state value of replication function is reached. Moving on, it is tested on a small size simulation with 3 communities of 15 nodes each and discovers that the hybrid simulation model has a higher hit ratio than traditional methods. Hitting up one scale, an urban scale evaluation with 50 communities of a total of 10,000 nodes is performed, in which the hit ratio takes longer to converge when more items are involved. Further on, a regional size study similar to that of a small country like Jamaica shows that channel recognition plays a vital part in the hit ratio for data dissemination. Final thoughts on this? The model was able to effectively disseminate data items across a wide range of popularities, which uses a very limited amount of storage space at each node, which is also important. The graph here shows the hit rate along time with and without channel recognition. It can be clearly observed that channel recognition offers a better hit rate than the one that doesn't actually use it. Kudos to the team to have performed a great depth of the study to understand and evaluate the model with ranging simulations from single community ones to nation level territories to thoroughly evaluate it and find a bunch of interesting factors and facts on each turn. I guess we have come to the end of my presentation. If you have any questions, do let me know. I'll Google them for you. Thank you so much for staying tuned. I hope you like the series of presentations. Have a good day.